Welcome, my dear children. After a long time, I thought of making a video lesson for your studies. Actually, the lesson is a chemistry lesson for grade 10 students. This is for the second term. And before starting the lesson, I just want to have a little chat with you. Even though your voice is not heard to me, um, the lesson is actually presented to you by using PowerPoint presentation, and then and there sometimes I explain by writing. And meantime, the lesson has actually the notes at the end of the lesson, so you can write down the notes. And sometimes while the lesson is being taught, you will have to pause the video and do some exercises, because some of the exercises have been given in between my lesson. So the video is only just for to give you some theories based on the quantification of elements and compounds. And another video will be there to support you after you answer the questions that I have given to you in between the lesson and at the end of the lesson, so that you can answer the questions and keep them ready with you when the second video is released. So there may be some difficulties that you are unable to reach to my video YouTube channel. But anyway, with the help of your parents or sometimes maybe your friends, you can find out about some of the information that I have given you through the YouTube channel. Anyway, with the minimum facilities that I have at my home, I prepare this lesson. Anyway, before going to the lesson again, I just ask you to give me sometimes WhatsApp comments, so then I can improve certain qualities that I can add to my future lessons. There may be some difficulties. Anyway, this is my lesson. So let's see the lesson. Unit 7, Quantification of Elements and Compounds. This is a grade 10 unit. So please make sure that you have a notebook or paper and a pen for a writing purpose, because there are certain areas that you have to write down. Pause the video when it is necessary. Mind the symbol appears there. And use the headphone if possible, because sometimes the sound quality might not be that much of perfect. You know that I'm not recording this one while staying on a studio. So, coming to the lesson, what did we learn earlier and what else do we have to learn? Well, the answer is competency 2. Competencies are designed for you to improve your education. In science, there are 3 competencies, I believe. And this is competency 2 for you to learn chemistry. And the competency 2 is to investigate matter, properties of matter and their interactions to enhance the quality of life. Again, investigates matter, properties of matter and their interactions to enhance the quality of life. So, the competency 2 has 2 levels. The first level is investigate scientific findings about the structure of matter. And that was actually introduced to you under Structure of Matter, Unit 3 of your textbook. And this is 2.2, uses mole to quantify elements and the compounds. So this is what we have to learn, and that comes under Unit 7 as a chemistry lesson, as I told you earlier. So to get back to the lessons. We have already finished investigates scientific findings about structure of matter under Unit 3. That was in your first term. And now about to start the use of moles to quantify elements and compounds under Unit 7. What did we learn from Unit 3? These areas were covered. I'm not going to read all. Planetary model of an atom started from there, and we discussed about the valency. That was the last one, starting from top, and we have already covered all these areas. Well, what do we have to study under 2.2? Uses moles to quantify elements and compounds. That is Unit 7. Atomic mass unit, relative atomic mass, relative molecular mass, Avogadro constant, mole, molar mass. So these are the areas that you have to study: 1, 2, 3, 4, 5, 6. And the first one, mass number, and that was earlier. Mass number is the total number of protons and neutrons in a nucleus. You have studied that the symbol, when the symbol is given, the mass number is given over here, and this is the atomic number. So the mass number is, as you know that when there is an atom, there is a nucleus. Inside the nucleus there are neutrons and protons. They are the subatomic particles with a mass. So the collection or the sum of neutron and proton indicates the mass number. Why did I discuss about the mass number? Because we are going to talk about the relative atomic mass. Because the relative atomic mass is very essential. Relative atomic mass will be used to discuss about the moles. And there are certain calculations when you go to the higher classes as well. So that's why I just want to highlight the atomic number at the very beginning. Well, get back to the lessons again. And atomic mass unit. Why another unit to measure an atom? If you can see, the mass of the unit relative to which the masses of other atoms are expressed is called the atomic mass unit. Atomic mass unit, and at present we select 1/12 of the mass of C612 isotope, carbon isotope, as the atomic mass unit. You know that atoms are very, very small, very tiny, and you can't measure them with the help of grams. That is why the atomic mass unit is introduced. So the atomic mass unit is taken as, you take mass of the carbon isotope, and that is taken by gram, and then divided by 12. You know why it is 12? Because neutron, proton, altogether the massed particles, there are 12. 12 massed subatomic particles are there. So that is why it is divided by 12. So then the answer is, you know that the mass of carbon is 1.99 times 10 to the power 23 gram, negative 23 gram. And when it is divided by 12, the answer is 1.67 times 10 to the power negative 24 gram. And that is the atomic mass unit. So atomic mass unit will be used hereafter, relative atomic mass, or AR. It is the ratio of the average mass of one atom of an element to 1/12 of the mass of an atom of carbon 12 isotope. Again, to highlight that, relative atomic mass, we say AR, mass of the element, atom, mass of an atom of the element. Then divide by 1/12 mass of C612 carbon atom, or we call AMU, atomic mass unit. Then you will get the relative atomic mass, or we call AR. If the real mass of an oxygen atom is 2.6 times 66 times 10 to the power negative 23 gram, and then we can get the true mass of carbon atom, C612 carbon atom is 1.99 times 10 to the power negative 23 gram. And then when the mass of an atom of oxygen is divided by AMU, you will get the relative atomic mass. So the relative atomic mass is calculated in that way. Well, when we go to the, no, one thing is that the relative atomic mass has no units because it's a relative value. So when we go to, the questions, as you know that this symbol indicates now you have to pause the video and calculate and find out the AR, relative atomic masses of sodium, chlorine, and potassium. You know how to do it. Mass of an atom, then divide by AMU. AMU means atomic mass unit. And these are some of the atomic mass units. And sorry, the relative atomic masses are given here. Among the list, children, there are some important elements such as calcium, potassium, chlorine, aluminium, magnesium, sodium, oxygen, nitrogen, carbon, and hydrogen. These elements are very important because there are lots of calculations with the help of these units. Therefore, it is better if you can remember the relative atomic masses of them. Normally, for your calculations in your test papers, these atomic AR or relative atomic masses are given. So no worries about that. But anyway, in order to save the time, it's better if you can remember them. And relative molecular mass. Relative molecular mass is, we discussed earlier about the relative atomic mass, and this is relative molecular mass. What is it? How many times a given molecule of an element, or we'll go to the unit, how many times a given molecule of an element or compound weighs as much as 1/12 the mass of C612 isotope is the relative molecular mass of that element or compound. Again, we can do the activity as usual the same way, if you can remember. Yeah, give me 1 second. You can see that how it is done. How can we measure? Method 1. There are two methods. Relative molecular mass can be calculated. Mass of a molecule of an element or compound divided by AMU, or 1/12 of the mass of a C612 atom. That is how we can calculate the relative molecular mass, and there are two methods. The first method is this one, and that is the longer method, the normal method. So the true mass of carbon dioxide molecule is 7.31 times 10 to the power negative 23. Mass of a carbon atom is 1.99 times 10 to the power negative 23. Then you know what to do. Take mass of a molecule of a carbon dioxide and then divide by AMU, or atomic mass unit. And atomic mass unit is calculated by dividing 1.99 times 10 to the power negative 23 gram by 12, and that is the mass of carbon atom. And after the final calculation, you will get the relative molecular mass of carbon dioxide is as 44. Okay, what about the second method? It is pretty easy. It's not the longer method. Relative molecular masses, it is done by finding the sum of all the relative atomic masses of the contributing atoms of the elements. Now, if you say it is carbon dioxide, so the carbon dioxide, carbon and oxygen are the contributing atoms, elements. Then I'm going to show you how it is calculated. Example, sodium chloride. How can we get the relative molecular mass of sodium chloride in shorter method? As you can see, it is done like this. Mr of sodium chloride is equal relative atomic mass of sodium plus Ar of chlorine. Ar of sodium is 23, Ar of chlorine is 35.5, and altogether you will get 58.5. If I'm correct, let's see, 58.5. And if you go to the another one, this is H2O. And there is one thing important. When you say Mr of H2O, you can see that 2H, hydrogen, there are 2 hydrogen atoms. Then you have to write it like 2 Ar of hydrogen. 2 Ar of hydrogen. That is why I included it like this. And 1 oxygen atom. So 2 times 1 plus 16, and finally you get 18 as Mr, or relative molecular mass of water. So then the calculation, the symbol indicates that you have to pause the video and find out the relative molecular masses of the given chemical compounds. And once you do complete these things and make them ready to find out my next video, so you can see how I do these exercises with you, so you can make it more clear when you watch my next video. And next one, Avogadro constant. Avogadro constant. What is this? Amedeo Avogadro was a scientist who observed this fantastic thing. And what is this fantastic idea? Actually, when a mass of any element equal to its relative atomic mass taken in grams, it contains the same number of atoms irrespective of the element. Irrespective of the element. What does this mean? What does this mean? If you select carbon 12 gram. And if you can count the number of atoms in 12 grams of carbon, it is 6.022 times 10 to the power 23 atoms are there. And the same way, if you select 16 gram of oxygen, why did I get 16 gram? Because the relative atomic mass of oxygen is 16. If you can remember, I told you to remember some important elements from that chart, from that table. And oxygen is there, chlorine was there. So if you select 16 gram of oxygen, there again you have the same number of atoms that the C carbon 12 gram contains. And if you say 23 gram of sodium, because 23 is the relative atomic mass of sodium, and if you say it is in gram, you will get the same number of atoms, 6.022 times 10 to the power 23 amount of atoms. This relationship was first found by Avogadro. So it is a constant, that is why the Avogadro constant, the name was given in order to make it an honorable honor for him. And then if it says that irrespective of, without considering the element, as you can see, carbon 12 gram, hydrogen 1 gram, chlorine 35.5 gram, and magnesium 24 gram. This is silver 108 gram. This is relative atomic masses. They are taken in gram. Then you will get the Avogadro constant. Not only not only the atoms, even it is common for the molecules. Let's have a look. When a mass of any substance equal to its relative molecular mass is taken in grams, it contains the same number of molecules. Same number of molecules that the carbon 12 gram contains. Again, if you can remember, if you can see, carbon dioxide, if you can remember that the relative molecular mass was of carbon dioxide was 44 gram, and H2O 18, I made a mistake. The relative molecular mass of carbon dioxide was 44, and if you take 44 gram, there you have 6.022 times 10 to the power 23 amount of carbon dioxide molecules. And H2 is a molecule. Hydrogen is an atom. When there are two hydrogen atoms, it makes a molecule. And Cl2 is a molecule, 35.5 plus 35.5, altogether it make it 71. So 71 gram contains the same amount of molecules. So it is just like this. If you take 1 dozen of books, how many books are there? 12. And if you say 1 dozen of countries, 12 countries, irrespective of sizes, the dozen is dozen. And irrespective of the molecules, whether it is carbon dioxide, whether it is water, whether it is calcium carbonate, the number of molecules in Avogadro constant, it is 6.022 times 10 to the power 23, and it can be taken when you take the relative molecular mass in gram content. So when you get back to my lesson, moles, and what is a mole? The mole is the amount of substance that contains as many basic building units or atoms, molecules, ions as there are atoms in exactly 12 gram of say 612 isotope. So it is the number of basic units contained in a mole of any substance is constant, and it is equal to the Avogadro constant. So mole is it is used to measure the amount of substances, and when you consider the molar masses, I want to get back to that one. 1 mole of sodium atom contains 23 gram of sodium. So if you go to the molar mass, the mass of 1 mole, the mass of 1 mole, it is again simple. As I told you that relative atomic mass is very important, relative molecular mass is very important, because it is the content that we use to express Avogadro constant, and it is the amount that we use to express about the molar mass. So if you consider 1 mole of carbon, 1 mole of carbon, the mass of 1 mole of carbon is 12 gram. And if you consider oxygen atoms, 1 mole of atom, its mass is oxygen 16 gram. And molar mass is that. What are the units of molar mass? So the units of molar mass can be gram per mole, gram per mole, or kilogram per mole. So molar masses can be divided into two as atomic molar mass, for example sodium 23 gram, and the other one is molecular molar mass. Molecular molar mass, it is give me 1 second, yes, coming back. It is the mass of, it is the mass of 1 molecule. It is the mass of 1 molecule. I just erased it. And then coming back to what is the next point we want to continue? And when we consider, when we go to the calculation can be done with the help of N equal M over M. N means number of moles, and M, simple M, is the mass. Capital M is the molar mass. Molar mass of the substance. So this is the end of this lesson, but still no, I'm not going to end my lesson. After this one, there are some exercises that you can do. You can pause each video clip and then write down the questions and work out the question. Keep your answers ready until my second video comes to you. And next, I have included the notes, where that you need, the notes are very essential for you to refresh your knowledge. These are the exercises. Exercises 3, I have included 2 exercises earlier. The symbol, the pause mark indicates that. Pause it and then go, and again. And meantime, Please go to your textbook and take the exercises there, write down them and do that exercises as well. Let's discuss the answers once we meet from our next session. Wait for my next video. And most importantly, these are the notes, if you can say. Given below are the necessary notes on the lesson. Please write down them in your notebook. Do the activities given under the exercises. I will discuss them on my next video. That's what I included. I do believe that my notes are clear, very clear, and can understand. In order to reduce the space, I have given you some of the clues where you can find out the certain things that you can include in your notes. So these are the notes, and if they are not clear, uh, again watch it again and again, and I hope that I have done something important to you, even though while you are staying at home and I'm not with you because of the prevailing situations, and I make it a point to respect all these people, those who are working hard to keep our country in a very good condition and to look after our health. So, and please pass this message that I have already done one lesson for grade 6 students, and hope to do another lessons for grade 11 and grade 9 as well. So please pass this message to them as well. And until then, I come to your doorstep with the help of another video. Stay at home and help your parents. Read your books and do something important. That's all. Have a wonderful and time. Goodbye.